Okay, so in this video we're going to take a look at how bones develop and how they grow. So let's see how that works. So the process of bone growth or new bone production is called osteogenesis. So we got two roots here, osteo for bone, genesis is for beginning, and osteogenesis occurs through the processes of ossification. So the calcification or the laying down of bony matrix. And so when we talk about osteogenesis and ossification, we're talking about the processes of new bone formation and of bone, what's called bone remodeling. So bone remodeling is the replacement of old bone material with new bone material. So it's just like a remodel job in the house. You're working to remodel the bones that you've got in your skeletal system. And it occurs, or osteogenesis occurs, with the replacement of existing connective tissue. So we have some connective tissue material that we've already got, and we replace that connective tissue with bony matrix. And all this is happening as the fetus is developing. So early in fetal development, the skeleton, or the elements that will become the skeleton, exist entirely as either fibrous membranes. So we have these membranous, fibery, membranous connective tissue, or as hyaline cartilage. So that cartilage where the fibers, the protein fibers in the cartilage, are clear. And so osteogenesis begins early in fetal development, like as early, I think it's 6 weeks, and it continues into adulthood as the body grows or as bones are injured and repaired. So here, the picture that we've got is showing an embryo early in skeletal development. And they've done a process to this embryo where they take it and do what's called clearing and then staining. So all of the developing musculature, the skin, has all been run through a process where it's rendered, see-through. That's the clearing part. And then they go through and stain the bony elements that are starting to develop a red color. So everywhere you see red is, and I've got a red pen, so the scapulae are developing. Here we can see the developing ribs. Those are where the bones are forming. And so you can tell that here in the brain area, the bony elements haven't begun to develop at all. Okay, so there are two methods by which bones develop. One is through intramembranous ossification, where bone tissue develops among the sheets of fibrous connective tissue. And so the skull is a good example of a place where intramembranous ossification occurs, because it's the bony elements begin as these fibrous connective tissue sheets. And then the second form, and if we look at the roots here, intra, within, membranous, within the membranes. The second form of bone osteogenesis is through what is called endochondral ossification. Endo means within or inside. Chondra, hopefully you're remembering that means cartilage. So this is bone formation that occurs as bone tissue develops within or inside of a cartilage model of that future bone. And so two types of bone osteogenesis. So let's take a look now at how some of this works. So here we have another embryo that has been cleared and stained. Now the intramembranous bones that are forming that form the skull are beginning to develop a little bit more. The fontanelle, if you have had a baby or if you've played with babies, that's the soft spot that's there at the top of the head. So there's a fontanelle here, There's also a fontanelle here. So the fontanelles form in the sutures where the bones meet, and their development, the fontanelles don't become bony until sometime after birth. So usually within about 6 months, 6 to 9 months following birth, the fontanelles have completely closed, and that allows for the baby's head to be squeezed a little bit as it passes through the vagina and through the passage, through the opening between the hip bones. So here's how intramembranous ossification occurs. We see that in the fetus, these membranous connective tissues develop. They're well vascularized, so there's a lot of blood supply to them. And within those membranes, progenitor cells that are going to produce the osteoblasts, they divide. Osteoblasts, remember, osteoblasts are the bone building cells, and they begin depositing bony matrix, forming spongy bone. And as lacunae form around these osteoblasts, then that's the point at which we declare that the osteoblast has matured into an osteocyte. So the most superficial of these membranes don't ossify. Instead, they form the periosteum, that layer of connective tissue that completely covers the superficial surface of the bone. Compact bone forms directly beneath the periosteum, and the spongy bone remains as a layer between the compact bone. So here we have the periosteum, then there's a layer of compact bone, really tight, then we have a layer of spongy bone, and on the interior surface, another membrane there does not ossify. That becomes the endosteum, and a layer of compact bone develops on the inner surface of the endosteum, and again, spongy bone in the middle, and so we wind up seeing this, a sheet of compact bone, another sheet of compact bone, and spongy bone in between those two, and that is the bone that's formed through intramembranous ossification. So this forms the flat and the sesamoid bones, so the bones of the skull, the mandible, the clavicles, the patella, the hip. These are all bones that form through intramembranous ossification. Okay, so the second form of ossification is that endochondral ossification. So here we have yet another cleared and stained fetus. You can see now throughout the body, here's the developing humerus, here are the radius and the ulna, here are the metacarpals and the phalanges, here's the femur, the tibia, and the fibula, and again the metatarsals can be seen, and right there, the toe tips, the developing phalanges are getting started there. So these bones, you'll notice that at the end, there's no bone there making the knee joint. There's very little bone here making the bulk of the hip. That's because these bones have not yet ossified, or these portions of those bones have not yet ossified. So with endochondral ossification, what we see is that everything begins as a cartilage model. Now recall, cartilage doesn't have blood supply, so this cartilage model is going to be limited in how large it can get before the cells, the cartilage cells here in the center of that model, run out of or don't have adequate supply of oxygen and nutrients. And so as the cartilage model gets larger, the central cells begin to die, and about that same time the blood vessels begin to make their way in toward the center. along the cartilage surface. First, though, periosteum begins to form, and that brings in some blood supply, and the blood vessels from the periosteum begin to penetrate toward the center of that developing cartilage model. Right at the periosteum, osteogenic cells will divide, and osteoclasts, I'm sorry, that should say osteoblasts. I apologize for that. I got ahead of myself, because the osteogenic cells can produce osteoblasts. So, following the development of the blood vessels, we see that osteoblasts are then delivered to this interior portion. So here underneath the periosteum, osteoblasts form, and as blood vessels penetrate into the center of the model, more osteoblasts form, and we start to see first the development of spongy bone, and then very quickly that spongy bone gets remodeled into compact bone. And we refer to this area in the center of the model as the primary ossification center, the first location that we see developing bony material. Now here at the epiphyses to be of this bone, we also see some of the same cartilage cells becoming becoming low on nutrients, and they begin to die, and we see osteoblasts invading the epiphyseal areas as well. So as osteoblasts invade into the epiphyseal areas, then more spongy bone begins to develop at what are termed secondary ossification centers. And here, back at the primary ossification center, we're seeing more and more compact bone developing here, and until eventually we get this region here and this region here. This is the only place where new bone can begin to develop. So in between the secondary ossification center and the primary ossification center. Okay, so let's move on to the next slide. Oh, before we get there, though, I want to just finish up discussing a little bit about what's going on here. So here at this secondary ossification center, in this region, this is the region of cartilage proliferation. So here on the epiphyseal side, we see lots and lots of cartilage developing. I guess I do want to go ahead and be here at the next, yeah, there we are. So here at the epiphyseal side, we see the development of lots and lots of cartilage. So it grows from this end. Here at this end, this is where that cartilage, as it's growing in this direction, is being converted into bony material. So here in the secondary ossification centers, the epiphyseal let me stop. Okay, see here in the secondary ossification centers, we bring in those osteoblasts. The spongy bone forms in the center, but compact bone develops around that secondary ossification center. Spongy bone will remain here in the epiphysis, so we'll have a big region of spongy bone, but we'll also, in the mature bone, see, or not, the maturing bone would probably be the best thing to say. We'll see a region that is still epiphyseal cartilage. And so that epiphyseal cartilage will keep growing and growing from this end, and at this end it'll be ossifying. And so as long as there's cartilage remaining here, then we have what's referred to as an epiphyseal plate that is going to allow the bone to keep growing. So as the bone matures, the only place that we see any cartilage is here at the articulating surfaces, and here, and at the epiphyseal plate. So then the way that the bone keeps getting longer is because we have this region of proliferation of cartilage that is sending tissue this direction, and as it makes its way in this direction, it will be converted to bone. And so as long as we have cartilage here, then long bones will keep growing in length, keep getting longer and longer, as long as there's cartilage there at the epiphyses, because the cartilage will keep growing in, sorry about that. Here we are. The cartilage will keep growing in this direction and will be converted to bone as it grows away from its area of proliferation. Eventually, though, as adolescence ends, those cartilage cells get slower and slower in their dividing, and the bone tissue begins to creep closer and closer until eventually there is no cartilage left and it all becomes bone. And that's what we're seeing here. So this is a mature humerus where the epiphyseal plate has closed, and that's why we talk about that. We talk about that as epiphyseal closure. And at the point where there is no cartilage left, it's all been converted to bone, then the long bone can no longer lengthen. And so for men, this happens late in adolescence, between the ages of like 18 and 21, 22. And for women, it happens much earlier, between the ages of like 14 to 16, are kind of the points at which most young women have finished any growth in bone length. Then last of all, as the bone develops, we see, and this can happen throughout life, as bones get stressed, we can also see not just growth in bone length. So this is again my poor drawing of the femur, where this is the ball of the femur, and here's the greater trochanter, and here is the joint with the knee. So we've talked about growth in bone length, but if we were to cut that bone across it, we'd see as well that there's growth in bone diameter. So here we have a child's bone, and most of this diameter here is filled with compact bone. Compact bone is very dense, very closely packed together, and it's heavy. So if the only thing that we did was add new bone material here at the outer rim, then we would wind up with very, very heavy bones indeed. But instead, what we see is a process that's referred to as appositional growth. So here underneath the periosteum, as the bone grows, we add new compact bone here underneath the periosteum. And so the bone keeps growing outward until we reach maturity. But rather than the bone being, the medullary cavity being only this large, what happens is there's regions where osteoclasts move in and they remove bone, so that in that mature adult, this region which used to be bone will all be removed. And I wish I had a way to now erase everything inside this circle. But what we're seeing is the boundary of the new medullary cavity, and instead the medullary cavity is now going to be filled with yellow bone marrow. And so this will be the zone of compact bone, giving the bone lots and lots of rigidity and strength across this portion of the bone. So the bone is grown in diameter, but because the osteoclasts move in and etch out and eat away at the medullary cavity, then the medullary cavity gets enlarged and the bone is lightened, so the weight of the bone becomes less massive. So that's appositional growth. And the more we use our bones, the greater the appositional growth will be. The more that we'll add compact bone here around the perimeter of the bone. Maybe I should be drawing it here because this is our mature bone. So we can increase the mass of our bones by adding more bone here at the perimeter. And again, in order to keep it light, then the osteoclast will move in and will etch out more of that medullary cavity. Okay, so here we've talked then about intramembranous ossification, the kind of ossification that occurs as to make flat bones and sesamoid bones, in which bony material or bony matrix is laid down in between membranes. And we've talked about endochondral ossification, in which there's a beginning cartilage model, and as the cartilage enlarges, then we see bony matrix replacing cartilage at the ossification centers and directly underneath the developing periosteum. And then we talked about growth in the length of the bone as the epiphyseal plates enlarge with cartilage, and that cartilage gets converted as well into bone. And then finally we talked about, and this wasn't in your book, so the only place you're going to hear about this appositional growth of the bone is here in this lecture. But in order to keep the bones light as they enlarge in diameter, the osteoclasts move in and etch out the medullary cavity, making it larger. And there we have it for lecture 7.4. 7.3. See in 7.4.